Mastering severity of failure. Catastrophic failures lurk in our most critical untamed processes. Where do the most critical operational processes that, if not performed correctly, have the potential to lead to catastrophic failures reside within our current systems and procedures, and what specific measures can be taken to ensure these processes are executed with the highest level of precision and reliability to prevent such failures from occurring? To address the critical operational processes that pose a high risk of catastrophic failures, a comprehensive approach is required to identify, assess, and mitigate these potential failures. This can be achieved by implementing a structured methodology to evaluate the current systems and procedures, and then implementing specific measures to ensure the highest level of precision and reliability. 1. Conduct a risk-based assessment. Perform a thorough risk-based assessment to identify the most critical operational processes that have the potential to lead to catastrophic failures. This assessment should consider factors such as the severity of the potential failure, the likelihood of occurrence, and the existing controls and mitigation measures in place. The assessment should involve a multidisciplinary team with expertise in operations, engineering, maintenance, and safety. 2. Map out critical processes. Create a detailed process map of the identified critical operational processes, outlining each step, task, and activity involved. This process map should highlight the key process indicators, KPIs, key performance indicators, KPIs, and critical quality attributes, CQAs, that are essential for ensuring the process is executed correctly. 3. Analyze failure modes and effects. Conduct a failure modes and effects analysis, FMEA, to identify potential failure modes, their effects on the process, and the likelihood of occurrence. This analysis should consider both human and equipment failures, as well as potential external factors that could contribute to failures. 4. Implement standard operating procedures, SOPs. Develop and implement SOPs for each critical process, detailing the step-by-step instructions, required skills and competencies, and necessary resources. These SOPs should be reviewed and updated regularly to ensure they remain relevant and effective. 5. Training and competency development. Provide comprehensive training programs for all personnel involved in critical processes, focusing on the necessary skills, competencies, and knowledge required to execute the process correctly. The training program should include theoretical and practical components, as well as regular assessments and evaluations. 6. Equipment and asset management. Implement a robust equipment and asset management program to ensure that all critical equipment is properly maintained, inspected, and calibrated. This program should include regular maintenance schedules, spare parts management, and obsolescence management. 7. Real-time monitoring and feedback. Implement real-time monitoring and feedback systems to track process performance, detect anomalies, and provide immediate feedback to operators. This can include the use of automation, sensors, and data analytics to improve process visibility and control. 8. Continuous improvement and learning. Establish a culture of continuous improvement and learning, encouraging personnel to report near-miss events, incidents, and areas for improvement. This should be supported by a robust incident investigation and root cause analysis, RCA, process to identify and address underlying causes of failures. 9. Independent verification and validation. Conduct regular independent verification and validation of critical processes to ensure they are being executed correctly and in accordance with SOPs. This can include audits, inspections, and assessments by internal or external experts. 10. Accountability and ownership. Clearly define accountability and ownership for each critical process, ensuring that personnel understand their roles and responsibilities in executing the process correctly. This should be supported by a clear communication strategy and regular performance evaluations. 11. Technology and automation. Leverage technology and automation to improve process reliability, where feasible. This can include the use of automation, robotics, or artificial intelligence to reduce the potential for human error. 12. Supply chain risk management. Identify and mitigate risks within the supply chain, ensuring that critical components and materials meet the required quality and reliability standards. 13. Emergency preparedness and response. Develop and implement emergency preparedness and response plans to ensure that the organization is equipped to respond quickly and effectively in the event of a catastrophic failure. By implementing these measures, organizations can significantly reduce the risk of catastrophic failures and ensure that critical operational processes are executed with the highest level of precision and reliability. This requires a sustained commitment to operational excellence, continuous improvement, and a culture of safety and reliability.